Hello everyone, good afternoon and welcome to this webinar on Earth observation in Africa, satellite data support for weather, hydrological and climate services. We continue from a session this morning where we heard introductions from the African Development Bank, from EUMETSAT and from the CDSF, and we heard talks from regional climate centres ACMAD and ICPAC, followed by a live question and answer session. If you missed the session this morning, you can view it on the EUMETSAT YouTube page along with this afternoon's session after we've concluded. We've had about 500 people registered now for this webinar, which is a brilliant result, showing just how important this topic is and will continue to be in the future. We'd like to thank again the collaborative efforts of the African Development Bank, the Climate for Development Africa Special Fund, CDSF, the European Organisation for the Exploitation of Meteorological Satellites, EUMETSAT, and Africa's 5 regional climate centres who have made this project possible. My name is Rachel Venn, and I'm working in Strategy and International Relations at EUMETSAT. I will be your host and moderator for the session this afternoon, following on from the capable and excellent example made by my co-host Mame Soke Sene this morning. I will now briefly lay out the agenda for the next hour and a half. First, we will hear 3 talks from regional climate centres ACRIMET, CAPC and SADC, representing West, Central and Southern Africa respectively. These RCCs will share with us the ways that they use satellite products for their own local weather and climate services. Following directly on from this, we are pleased to present a roundtable discussion between the African Union Commission, African Development Bank, World Meteorological Organization and EUMETSAT. This panel of 4 people will discuss the future perspective for Earth observation activities in Africa. After this, we will have a question and answer session in the same manner as this morning, where presenters will answer questions sent in by you. To send in your questions, please use the Slido tool via the link we sent to you with this Zoom link, in the chat and at #EOAfrica. We do have limited time, so I'm sorry in advance if we can't answer every single question live. Final housekeeping notes for this webinar. Please be aware this webinar is being recorded and uploaded to YouTube, where it will be available publicly and continue to be available after this event. If you're joining us on Zoom, interpretation is available in English and French, where you can access by clicking the globe icon at the bottom of the screen. Finally, please share on your social media channels by using #EOAfrica. I'm now pleased to present our first presenter. Dr. Seydou B. Traoré is an agrometeorologist at the ACRIMET Regional Centre based in Niamey, Niger, where he is in charge of crop monitoring and yield forecasting for food security early warning since July 2000. Besides operational activities, he also conducts research towards the improvement of the crop monitoring tools and methodologies, and studies on climate change impacts on crop yields in the West Africa region. In this regard, he took part in several international research initiatives, such as the African Monsoon Multidisciplinary Analyses Project, the Agricultural Models Intercomparison and Improvement Project, and the Climate Change, Agriculture and Food Security Project. Dr. Traoré was one of the thematic experts in the African Monitoring of Environment for Sustainable Development and its follow-up, Monitoring of Environment Security in Africa, both dealing with and making use of Earth observation data to help decision-making in agriculture and natural resources management in West Africa. Dr. Traoré is currently the manager of the SAWIDRA product, dealing with supporting West African countries in seasonal climate forecasting and numerical weather prediction for disaster risk reduction. Seydou, you have the floor.
Okay, thank you, Rachel.
Thank you, Seydou.
So, let me share my presentation. Are you seeing it?
Yes, that looks good. Can you just check that you can move between slides for us?
Okay, so thank you very much. My name is Seydou Traoré, and I am going to present the operational use of satellite products in West Africa and the Sahel. So here is the outline of my presentation. First of all, I will give you background information about AgriMet Regional Center. Then I will go through the various products we are using derived from satellites for the rainy season monitoring, starting with rainfall monitoring, also vegetation monitoring, crop monitoring and yield forecasting, water resources monitoring and flood forecasting, also weather forecasting, and also some products we are developing in framework of climate monitoring and agroclimatology. Lastly, I will name some partners and colleagues who help prepare this presentation. So the AgriMet Regional Center it was created in 1974 after the drastic drought that the Sahel region has known. And it is a specialized institution of SILS, which stands for Permanent Interstate Committee for Drought Control in the Sahel. The mission assigned to AgriMet is to contribute to achieving sustainable food security and rational natural resource management through capacity building and also the production and dissemination of information to various decision makers. AgriMet covers all the 17 SILS and ECOWAS member countries in West Africa. And it was recently endorsed by ECOWAS Commission as the West Africa and Sahel Regional Climate Center, RCC. Here is the operating scheme at AgriMet. At the center here, you can see the AgriMet itself with its different disciplines, the specialists in different disciplines, namely hydrology, meteorology, pastoralism, agriculture, food security and nutrition. And also you have other specialties such as GIS and remote sensing specialists. So those are the team at AgriMet here, and each of these experts interacts with correspondents at national meteorological agencies or other agencies in member countries. Those also have been organized by AgriMet around what we call multidisciplinary working groups. So they meet regularly to share the information they have and produce also national bulletins. They are the ones who collect the ground data, be it meteorological or agricultural statistics, hydrological data, or any other type of data, including socioeconomic data, and they share them with us at AgriMet. And also, AgriMet is using satellite data. Initially, it was based, receiving stations were based only here at AgriMet, but thanks to the AMES and MESA projects, we managed to install both receiving stations in all member countries, including national med services. So they also can collect those data. And so we use the combined satellite and meteorological data to elaborate our information and share those information with all stakeholders, including financial and technical partners. So let me now talk about the rainy season monitoring activities. First of all, since the onset of the season, we regularly have decadal monitoring. Every 10 days, we have briefings here at AgriMet where we examine the different products and to assess what is going on concerning the rainy season. These are examples of maps of cumulative decadal rainfall. I just gave two cases, the end of April, where the rainy season is already installed in the southern part of West Africa, the Guinea Gulf countries, while still in the Sahel, we are waiting for the rainy season. And in August, where the heart of the rainy season here in West Africa, and all the Sahelian and Sudanese zones are covered with rainfall. Beside the cumulative maps, we have also maps of anomalies, which is a comparison between the current year and the different references, could be last year or could be the long-term averages. And you see in the yellowish areas are where we have observed some deficit rainfall compared to the reference, and the blue areas where we have observed some excellent rainfall in those areas. Here are maps for this 2020 year. One can see that the Sahelian band witnessed a lot of accident rainfall this year, which has actually caused some floods in the region. Okay, after the decadal scale, which we do mostly through briefings, we also publish our regular monthly bulletin where we analyze monthly values in terms of cumulative rainfall or in terms of anomalies relative to 30-year references. And this one also, we use satellite images to do this kind of maps. Rainfall estimations are also used to assess where there is some favorable condition for desert locust breeding areas. You know that those pests are really a big threat to agriculture and pastoralism in the region. And this morning, the representative from ICPAG talked about what was happening this year in the Horn of Africa. But in the Sahel region also, we have a big threat for desert locust invasions. And the tool we are using to monitor and to warn early about this is wherever there are favorable rainfall conditions in those areas, the breeding areas, which are represented here in red polygons. So if it rains there, which is an early signal of possibility of them breeding, so the crop protection agencies can take measures either to control them or make sure that they do not breed and spread down to the agricultural fields or pasture lands. Besides rainfall, we also monitor vegetation condition. Here are two maps representing anomalies of the NDVI. And for example, last year in 2019, we had some very critical condition in northern Senegal and southern Mauritania, consecutive of several years of lack of rainfall and deficit, but somehow it has improved toward the end of 2019, which you can see here on the map. Vegetation monitoring also consists also on deriving potential biomass. So this is very useful for pastoralists to inform them about the availability of biomass in pasture lands. And from there also we can deduct the livestock carrying capacity in each of those areas. This helps a lot pastoralists to move around the West Sahara in the framework of their transhumance activities. Okay, the measure station also allow us to do some comparative analysis. If we, for example, spot some particular area, we can also draw some profiles to compare how the rainfall situation impacted on the development of the vegetation. So here, for example, I just talked about northern Senegal in 2019. We can see here how the rainfall situation evolved and also how vegetation also evolved below average vegetation situation till toward the end of the season where we see things start to become normal. And on the opposite, in southern Chad, we see that since the beginning of the season, conditions were very favorable, above average rainfall observed, and which resulted in very good vegetation condition, almost reach record situation throughout the season. So all of these products can help analyze the ongoing situation and give right information to decision makers, both at administrative level, but also to users on the ground. We also use satellite-derived rainfall estimates to force biophysical models. Here is the example of a crop model, modeling called SARA-O, where with this model we can assess whether where sowing dates were available, were possible since the beginning of the season, and also analyze them relative to the reference year or average years. And also the same model allows also to assess the water requirement satisfaction of different crop types, mostly cereal crops, maize, sorghum, millet, and also toward the end of the season also project on the potential yield anomalies awaited from this the current year situation. Here, for example, we have anomalies of awaited anomalies of crop yield, of maize yield for this ongoing season. We will update also this map at the end of September, and this is very useful for also national agricultural statistics agencies, particularly in areas where, because of ongoing insecurity, the team cannot go and assess on the ground. So the satellite proxies can help them also have an idea of how the crops are growing and which yields are expected on those areas. We also use satellite-derived rainfall estimate to assess water availability in different river basins. Here on the left, you have a map of West Africa river basins, and the monitoring of water in those basins also can be done using hydrological models, and also the same models also can be forced by satellite rainfall estimate to forecast and to assess flood risk for the next 10 days to come. So this map is actually was derived from, so it shows the risk of floods. The red areas are the most likely areas to experiment flood from the output out with this model. We have also the Puma stations that were installed since the early 2000, and they were upgraded with the MSZ project and also the MESA project. And AgriMet help install those stations in national meteorological agencies and keeps maintaining them. So they use those images to forecast the weather at the airport and for general public. The framework of the SAWIDRA project, AgriMet has acquired a weather forecasting model called the WRF, and it has been parameterized so to allow to do a weather forecast for the next few hours. It is very short-term forecast. For example, you see here some example of forecast for the next 12 hours or the next 24 hours, and it can do forecast for the coming days, be it for rainfall or for other climate parameters such as maximum or minimum temperatures. The same model also can represent its output in form of probabilities of getting some rains with a given threshold. For example, we have two examples here. The probability of getting 25 millimeters in the next 24 hours, or 50 millimeters in the next 24 hours. So in the perspective, actually in the framework of SAWIDRA project, it is envisaged to install satellite receiving antenna, RAS antenna, so that by assimilating satellite data for those antennas, one can significantly improve the quality of this forecast. So they will become even better quality for the use by national met services and disaster reduction agencies. We also use satellite data, mainly rainfall data, to do some climatological analysis. For example, these are daily rainfall values for the past years, So since the beginning of the satellites, one can recall what were rainfall patterns each day. For example, here we have an example of 2016, but this was done through the IRI data library. So IRI based in New York, they help the set up this system here at AgriMet. One can go back to historical records and plug them and share them with users. The same platform can help also us to compute different climatologies. For example, this is an example of monthly, average monthly rainfall for the June month in West Africa, or for the August month in West Africa. And also, we can also calculate the onset date based on rainfall thresholds. And you can see two different contrasting years in terms of onset date of rainy season. So all this is possible using the data library platform we have here and historical satellite data on record. So I finished my presentation by acknowledging some partners and also colleagues who helped me prepare this presentation. I can name EUMETSAT, GRC, Vito, FuseNet, IRI, CIRAD, ACMAD at the international level. We have also national meteorological and hydrological agencies, national agricultural research institutions, universities, and other partners, and my colleagues here at AgriMet who contributed to this presentation. With that, I thank you for your attention.
Thank you very much, Sedo. It was an excellent talk. It was very interesting, and I'm sure that everyone has learned a lot. Next up, our next presenter is Dr. Pascal Moody, who is a numerical weather prediction specialist at the First Regional Climate Centre for the Central African region. Prior to this, he worked in aviation forecast for Asenka. A specialist in climate and meteorology since 2006, he has deep expertise in weather modelling, forecast techniques, and satellite data interpretation. He is a team leader for the Laboratory of Atmospheric and Environmental Modelling and a member of the Cameroon Academy Science Association. Dr. Moody holds a PhD in atmospheric physics. I'll give the floor to you, Pascal.
Thank you, Rachel. Thank you, dear colleagues. Ladies and gentlemen, I would like to thank the AfDB and the EUMETSAT for the opportunity that have been given to the Climate Application and Prediction Center in Central Africa to give this presentation. My name is Dr. Pascal Moody Igri. I'm the numerical weather prediction in the framework of the SAWIDRA project based in Central Africa in Douala. Our presentation will go through the template that have been shared by the colleagues. And we can say that the Climate Application and Prediction Center for Central Africa has been established in 2015, and it is located in Douala, in Cameroon. The climate application, the CAPC, works behalf on the 11 countries in the CAPC, in the ECAS regions. The mandate of the Climate Application and Prediction Center for Central Africa is a specialized institution of the ECAS in charge of implementing meteorological and climate policy in the region. The CAPC is therefore an international governmental organization in charge of the execution of a mission of public service on behalf of the 11 countries. So we also aim to implement of up-to-date climate services and products to serve as resources and tools for national med services and to strengthening the capacity of the national med services. So the aims of the CAPC is to provide good quality climate services to users at national levels, reducing vulnerability to climate change, creation of conditions of climate resilience, to contribute to disaster risk reduction and to give input to integrating adaptation into decision-making process via climate services products. And also our decision makers and end users and national services, university, different private sectors and local communities, our donors and partners at EU, ACP, AfDB, ACMAD, EUMETSAT, and also different regional climate services. The application that we are involved in at CPC are mainly agriculture and food security, environment, water resource management, early warning, health, energy, planning for development, training and education. So ladies and gentlemen, in the framework of the SAWIDRA project, the objective was to improve the core capacity of the CAPC itself and also the National Meteorological Services to meet the needs of disaster risk management agencies and socio-economic sectors for effective use of weather and climate services and community focus and real-time early warning systems. So the impact is that resilience to meteorological disasters in ECAS countries is improved. So in the framework of the SAWIDRA, we have been quite developing a lot of products, including seasonal forecasts using satellite data as initial conditions. Our products are developed at different time scale. Here we are using the seasonal forecast at 3 months lead times. So you can have different categories that are very much above normal, normal condition, below normal condition, and much below normal condition. So these products can have idea on how the precipitation will be distributed in different countries, given the anomalies, the total accumulation, and also the seasonal performance forecast. So going from the seasonal forecast to the monthly forecast, we can also monitor how precipitation and weather can be distributed at a monthly level. So this is the product, the forecast for the October months coming. And we can see that here we have a lot of rainfall that are expected to fall on the Congo and Gabon regions, giving the different categories that can help government and disaster risk reduction to really take advantage of this kind of product and to be prepared for the event that will happen. At the CPC, in the climate, in the SAWIDRA project, we also do the climate monitoring, let's say the drought monitoring via the sub-seasonal forecast. So here we have the forecast that is developed based on the different satellite data that we receive. And then the product is developed at such a way that non-specialist people can use them. So we have assigned some color that can help people to interpret the product that we have developed. So after the issuing of this product, we are also doing some verification using satellite data so that to make sure that the product that are issued in the framework of the SAWIDRA are accurate and can help reducing risk reduction. So here we can also follow via the same products, we can monitor the flood events, showing that when we have the green color here, it means that we have very above normal condition that can lead to some floods in the region. So an example on what we have been doing is shown here is that this slide, we show the collapse of the bridge in the Marwa, the final region of Cameroon on 21 August. And you can see that on that day, the satellite image can show the mesoscale convective system that hit that region that day. And also here we have the product, the sub-seasonal product that we have generated on 40 August, let's say 2 weeks before that collapse of bridge happened. So it means that we focus for this period the high above normal condition that could lead to floods in this region, and effectively this day we have the collapse of that bridge that has a very high impact on the socio-economic activities in this region. We can also show this example on 2 at the beginning of the month of August that you have an air crash at the Marwa Salak Airport, when we have also forecast the very above normal condition in this region with this WMO matrix showing that people should be prepared for this day because high rainfall are forecasted in this specific region. So the products that we are generating for the high impact weather, let's say the warning, the alert, advisory, and the watch, is based on the WMO matrix that give you different probabilities of the event that will happen and also the impact associated. So the aims is to come with a product that will give you not only the amount of the rainfall that is forecasted, but also will give you the probability at what extent this situation will happen. So here, when you have the orange color, it tells you that please be prepared because some special events are forecasted and will happen. Given what we have also developing here at the CAPC, we also have the monitoring of the food agriculture, the food, and also the energy, which can give you the information on how people can be prepared to choose their crops, and also how they could choose the field to prepare their fields, and also what are the timing of the planting, the weeding, and the harvest. So people can be prepared on the operation on their dams, and people can also prepare evacuation in the case of outbreaks. People can also monitor drought and monitoring flood. So this is a view, an overview of the different products that we have been generating in the framework of the SAWIDRA project using satellite data that are very useful because this region is also a region where station data are not really available. We can also follow the onset, the duration, and the retreat of different seasons using satellite data. And here we can have this product that show how we can monitor the Nigeria and the Cameroon regions with the different satellites that are available. With this product, you can have the onset date, the duration of the season, and also the retreat of the season, and the different variability of the data that will be generated in this period. Using this product, farmers, government, and all the organizations that are working in the framework of the agriculture and so on will take advantages of this data to prepare their activities. The important things that we have also doing is the monitoring of the lake shade basin. We can remark that over the last decade, the surface of the lake shade has been reducing for about 80%. And this can be the result of environmental change or the climate variability. In the framework of the SAWIDRA, we can monitor using satellite data how the lake shade is recovering from the long period drought that he has experienced, and that using this, we can have the trend showing that this region is recovering for the long period of drought. So we have a positive trend that is now showing in the region of the lake shade, and people can then prepare for some special event that could happen after this period, because the recovering from the drought now can lead to some special event like droughts and so on, floods and so on. So this slide shows how we can also, in the framework of the SAWIDRA using satellite data, monitor the extreme events that happen in the Central Africa for different years. And this slide shows you how you have the extreme event that happened for the year 2019 and 2020, showing that we have more floods that happen in the regions of Cameroon, in the far north region, and also different other regions in the region. So this slide shows how at the CAPC in Douala, Cameroon, our technical scheme is that we are using data simulation as input to the HPC that we have acquired in the framework of the SAWIDRA project, using the satellite data from the RAS antenna that will be installed to the different sites that Ahmad shows previously this morning. And also we can use the Puma station that we are having some specific data via the MESA, and all these products will be combined and will be used in the early warning system, that is the meteor factory equipment that we are acquiring, and then we will then develop some special products that are tailored products. So that we are going to do is not just to develop products, but we are developing this product based on the needs of our users. So the equipment that we have acquired in the framework of the SAWIDRA will use satellite data as input, and then we will having tailored product for the different economic sectors. So for us here at the CPC, our need is to have a data center that could lead to develop high quality weather prediction for different sectors that will be used for as our users. So ladies and gentlemen, as a summary, the aim of the CPC is to strengthen the core capacity of the National Meteorological Services in delivering timely and accurate weather and climate forecasts for extreme events in the region. So now weather and climate information are generated for different applications. The main issue that we are having now remain at the level of the preparation and responses at national or regional level. It's time to say that even accurate weather forecasts are issue, so people are taking their time to respond adequately to the alerts that are generated. So advanced forecasting techniques are needed so that information on the early onset of rainfall can be communicated to farmers in real time and with high quality. In general, the observed increase in rainfall could be beneficial for biodiversity, agriculture, and pastoral activities, but floods also have negative social impact consequence on destruction of property and crops. So, ladies and gentlemen, this is the presentation that have been prepared by the Climate Application and Prediction Center. So I would like to thank you one more for your kind attention.
Thank you very much, Dr. Moody, for an excellent presentation. Very interesting, well presented, and I'm sure everyone has learned a lot more about climate activities in Central Africa.
Thank you.
Our final presenter for today is the final RCC. We have Dr. Prithviraj Buniyadi, who has come from the South African Regional Climate Center. Dr. Prithviraj is a Senior Program Officer for Meteorology, heading the Meteorology Unit at the SADC Secretariat in Botswana. He's the former Deputy Director for Mauritius's Disaster Risk Reduction and Management at the National Disaster Risk Reduction and Management Center. Prior to that, he spent over 13 years at the Mauritius Meteorological Services. He's also worked as meteorological technician and has taught physics and computer science at secondary level. Dr. Buniyadi holds a PhD from the University of Mauritius. His thesis title was Climate Change Indicators for Policy Formation, Climate Change Adaptation. Dr. Prithviraj, I hand the floor to you.
Thank you very much. Let me see if I can share my screen, hopefully.
To share your screen, you can press the green button on the Zoom call.
Yeah, this is what I'm trying. It's coming now. Very good. So, am I audible?
You are.
So. Thank you very much.
Thank you.
Thank you very much. And good afternoon, everyone. Good afternoon, colleagues. I'm Raj Buniyadi. And thank you very much, Rachel, for the introduction. So my presentation will be on satellite and data support for weather, water, and climate services in the SADC region. The outline is as follows. I'm going to give you an introduction about the SADC Climate Services Center, some of the projects that is more related with Earth observations, the products and services that are currently being generated, the outputs, achievements, the impact so far, and finally lessons learned. So SADC Climate Services Center was established in 1990 as the Drought Monitoring Center in Zimbabwe, basically monitoring the status of the drought in the SADC region, at the same time issuing a few advisories, especially to decision makers and stakeholders. Since 2002, the SADC CSC is under the SADC Secretariat, hosted by the government of Botswana. The CSC basically develops and disseminates climate weather information and provides some operational services, basically monitoring and predicting extreme weather events and issuing advisories to national meteorological and hydrological services of the member states in SADC, who at their level, they assess the situation on ground and issue their own advisories and warning at their level. As Dr. Andre mentioned earlier, ground observation is quite scarce in the SADC region. And so the CSC mostly uses satellite data to provide for the limited access to the information on ground. The applications and products developed at the CSC are mainly first the SOCOF products. As you might be aware, the SOCOF is here and we are convening annual and biannual meetings in the past 24 years. And we did one this year in August, and we issued the seasonal warning and the early warning advisory bulletin in September this month. We also issue advisories on extreme weather events and as well as produce diagnostic bulletins that we upload on our website. Our users are mainly from climate sensitive sectors such as agriculture, food security, water, energy, disaster risk reduction, and health, as well as decision makers in the region and internationally. We have research institutions who are our users and the public at large. So as I was saying initially, mainly the SADC CSC has been implementing projects that aim to improve the capacity of the center as well as its member states, that is the SADC member states, to access and use Earth observation data. Here's a list of projects that we have been implementing, starting from Puma, AMESD, MESA, ISASIP, and currently we are implementing the SAWIDRA SADC, which we name it as Southern African Regional Climate Information for Disaster Resilience Development. It started in 2017 and it is ending this year. The next project is the Intra-SAP Climate Services and Related Applications Program. We signed this project last year and it is for a period of 4 years. The products and services, for nowcasting, we use a 15-minute satellite image from the EUMETSAT MSG station to monitor the current weather patterns. For example, the tracking of weather systems and storms. And at the same time, you see one of my colleagues here sitting in front of the station, monitoring the weather pattern that is evolving over the SADC. This slide is basically showing one of the applications that we do. One of the products that we issue is through seven-day forecast, which we issue running the numerical weather prediction on our cluster, which we procured under the ISASIP. On your left-hand side, you see some of the products that are generated daily and uploaded on our website. You can see it there. And on the right-hand side, it shows one of the products that were generated, where you see a storm which is evolving just north of Madagascar, and eventually affected, giving huge amount of rainfall, significant rainfall over Madagascar. And this allowed us to issue a timely advisory to the Madagascar, Meteo Madagascar, where they took appropriate steps for them to, monitor at their level. During this SAWIDRA project, we are procuring also high performance computing server to be delivered to 14 national meteorological and hydrological services in the region. First, for them to access the satellite information, and at the same time, on the left-hand side, you can see there's infrastructure that is being provided. It is just indicative. It is not the same one, but it is just indicating the infrastructure that has been provided to the member states. And on the right-hand side, you see certain capacity building that we conducted during the project itself, that is a SAWIDRA SADC project, where we trained national meteorological and hydrological services experts on administration of the HPC to start with, the numerical weather prediction, and then regional climate modeling. This slide shows basically how we use rainfall estimates from satellite blended with ground station data to assess the situation on ground. On the left-hand side, you see a SADC image, which is showing the total precipitation that was estimated using chirp data. It shows the dark spots, indicating region where there is a significant, where the data is significant, and we can also assess that we can use it to estimate how the OND precipitation trends are for the period 1981 to 2010. On the right-hand side, it is what we do. Actually, we use this type of data to project the consecutive dry days for the period October, November, December to January, February, March, percentage change in the rainfall based on RCP 4.5. Here is an example of use of thermal channel on board satellites for monitoring land surface temperature and active wildfire in the region. On the picture further down on your left-hand side, you see an image taken by MODIS in 2012, showing the extent of wildfire damage in Namibia. This is an example that I have taken from a MESD product, and eventually that caused significant death of wildlife in the region. And the same technique was used in Mesa Wildfire Station during the Mesa project to install this type of facility so that member states use satellite images and satellite-based data set to monitor wildlife as well as wildfire in the region. This slide shows the use of vegetation product based on satellite data. On the top left-hand side, you see an image showing standardized difference vegetation. This is for last year, April. You can see it is based on accumulated information that we have for the season. So we generate this type of information to see what is the extent of vegetation. So you can see as well the red spot indicating the dryness, especially in the region of Angola, Western South Africa, most part of Botswana. You see also Southern Angola, Zambia and Zimbabwe are also affected. So this is just an indication of how we use it. And the pictures on the right-hand side, that is the one at the bottom, it is showing the accumulated rainfall status estimated from satellite data. So it is indicating the extent of dryness in the region for the period October 2018 to March 2019. that allowed us to issue advisories regarding the drought, and member states also eventually declared and also have declared drought during those periods. Outputs and achievements. This slide shows the way we disseminate our information. Normally we use our website and we send emails to national meteorological directors of national meteorological and hydrological services who get access to this type of information, assess the situation on ground, and then at their level, they issue national advisories or warnings. We also issue some of the products on social media and user forum. On the left-hand side shows some of the early warning products that we have generated so far. And on the right-hand side is the Climate Outlook Forum for last year that we conducted in Angola. This slide shows a sort of weather alert system, I would say identical to the meteor alarm in Europe that we are currently developing under the SAWIDRA and SAWIDRA SADC project. It is a platform that will allow member states to upload their weather alerts, and it will be available to public. It is still under preparation, and hopefully we will complete it within the lifetime of the project. Impacts, as I was saying, first is the DR agencies. So whatever products we are issuing, the DR unit, especially at the SADC Secretariat, there is a DR unit who use this type of information to enhance preparedness and response in disaster. National meteorological and hydrological services, we are expecting them to improve weather and information through the infrastructure that we are providing them, namely automatic weather stations, high performance computer server, automatic message switching systems. And also we have enhanced the capacity by segment of experts and training workshops that we have conducted during the projects. The SOCO process has also been improved. We have now a platform where water, health, energy, transport, agriculture, and disaster management community come together, and we develop a sort of preparedness and response strategy for the upcoming rainfall, and hopefully this will be improved further. Community, we are interacting with local users. For example, we bring in farmers and farmers union, community leaders, sometimes youth, and as well as people, those who are in disaster-prone areas, to take appropriate actions. So here at the bottom, you'll see one of the products that we issued last year on 8th of November last year, a sort of advisories that we sent to member states, indicating them of chances to have a significant rainfall, and eventually you see there has been rainfall in the region with significant impact. So at the same time, vegetation and rainfall performance and seasonal rainfall forecast was used in Botswana, for example, in 2015 to analyze the situation on ground that assisted Botswana to declare the drought in the region. Lessons learned, or we can take it as a sort of recommendation as well. We find that for SADC, satellite observation is crucial to ensure a continuity in the provision of the services, especially now that we are getting more satellite images and more products. For example, the Copernicus Climate Change Service that is providing free access data. This has to ensure that we have a continued support from this type of services. EUMETSAT, Meteosat second generation satellite are nearing end of life, and there is a need to uptake the Meteosat third generation satellite products and ensure member states as well as the SADC CSC is fully equipped to receive this type of products and take best advantage of it. It's rather showing you the center itself. and the HPC on the top right-hand side, as well as how we operate at the CSC. You have the contact details at the bottom. We are based in Botswana, and the email, as well as the website. I thank you all for your attention. Thank you very much.
Thank you very much, Dr. Buniadi. An excellent presentation. What we're going to do now is we're going to field to you presenters a few questions from the Slido link in a short question and answer session. I'll ask that you keep your answers brief, but we only have a few to ask so far, so there'll be a couple of questions each before we move on to the roundtable discussion. First question I have is for Dr. Sado. The question is, did you use your short-term range forecasts to alert or provide vigilance bulletin to NMHS during the various flood events the Sahel faced this September, Dakar and Niamey flood events? Are you also planning to develop and use medium-range forecasts?
Okay, thank you. Thank you very much for those questions. The short-term weather forecast agreement are still on, how do you call it, on experimental phase. We have acquired through the SAWIDRA project the necessary equipment and models, and those models have been parameterized and tested. But so far, we have not starting to share it with meteorological agencies. We, of course, run some on-the-job trainings to use the tools and also to demonstrate how, when the full equipment will be installed, how which kind of product will be benefiting from us. But right now, we are not sharing them with the national agencies. And regarding our perspective to use also a short-term forecast for our activities, yes, we intend actually to use those for an agreement here, not only because, as I said in my presentation, we are using those data to force biophysical models. We have crop models, so based on the observed data from satellite, you can also use the forecast for the coming weeks or even months to assess crop growing conditions and potential yields. The same thing stands for hydrological models to forecast likelihood of floods. So we intend very much to use the forecast, be it short-term or a medium range forecast for our regular activities.
All right, thank you very much. The next question is to Dr. Pascal. The question is, I want to know if your centre can provide master's students who want to learn hydrometeorology. Can you?
Hello, please, can you repeat? I haven't captured the question.
Okay, I'll post it in the chat as well so that everyone can see it. This question is, someone would like to know if your centre can provide for master students who would like to learn hydrometeorology.
Yes, so thank you for the question. As I present in my talk, the Climate Application and Prediction Center is a training center. So the one function that we are going to fulfill is to give training to students. So for the moment, the center is not really set up because we are just at the beginning of the implementation of the activities of the center. So thanks to the SAWIDRA project, we are now implementing our activities. So shortly, when everything will be okay, we have the expertise to have students here for different activities regarding hydrometeorologicals and so on. So This is something that is planned, and we also have some modules that are developed for training and so on. Yes.
Right, thank you very much.
Yeah.
The next question goes to all of the presenters, whoever may wish to ask. And this question comes from Ua Nasiru Umar, a PhD research student from the Department of Environmental Management in Bayero University, Nigeria. Umar asks, please, how can we research students have access to some satellite data? Not only that, can we share with you a presentation? I will answer the presentation one now. After this, if you have been signed up and registered for this webinar, which you should be because you're in the Zoom call, we will distribute all of the presentations and PowerPoints afterwards. So you'll be able to download the presentation files. The question for the presenters is, how can we research students have access to some of the satellite data? Raj, can you answer this?
Thank you very much. I think it is a very good question. In fact, I don't know whether the student is aware, we have the MESA project where certain stations were provided to research institutions as well as universities. So I think it is acceptable that they could access it through these institutions, that is the specific university that was identified, so that they can have access to live information. Or else for SADC, there is no problem for us to invite students and accommodate students to come as a sort of attachment or even in secondment. But it all depends on the modalities for them to come and to have access to this type of information. And at the same time, I think satellite images are available on the EUMETSAT portal, and can be accessed using internet, and it is relatively near real time. So the students, of course, can track the situation and analyze at their own, the situation on ground. Thank you.
Okay, thank you very much, Raj. This concludes our question and answer session and our contributions from the panelists. I'd like to thank again all of the panelists who have spoken today, all of the representatives from the regional climate centres for your brilliant presentations and excellent contributions to this webinar. We now begin the final phase of the webinar, which is a roundtable discussion on the topic, Future Perspectives on Earth Observation in Africa. I'm delighted to present 4 fantastic panelists for this discussion, who between them have a massive range of expertise across aspects of meteorology, public policy, and Africa. For the sake of time, I will ask our panelists to keep their responses brief. And please, may all 4 of you turn on your cameras now and prepare for the presentation. I'll begin to introduce them. Our first panelist is Balgis Osman El Asha from the African Development Bank. Dr. Balgis is a Chief Climate Change and Green Growth Specialist at the African Development Bank. She is a forester by training with more than 20 years experience, spanning natural resources management, renewable energy, and green growth, with a special focus on the human dimension of global environmental changes and their impacts on sustainable development. She is a forester by training and holds a PhD in forestry. Dr. Balgis Osman El Asha is the winner of the UNEP Champions of the Earth, awarded to outstanding environmentalists from 2008. Our second panelist is Mr. Gatkuoth Kai, who is the Technical Coordinator for Disaster Risk Reduction from the African Union Commission. Mr. Kai is a development and humanitarian expert with over 15 years progressive experience in leading several development initiatives and life-saving humanitarian interventions. He holds a master's in risk, crisis and disaster management from the University of Leicester in the United Kingdom, and he also holds a master's in project management. At the moment, he heads the Disaster Risk Reduction Unit at the African Union Commission, a role he is passionately contributing to development and strengthening of institutions and systems of governance for disaster risk management at continental, regional and national levels. Prior to joining the African Union Commission, he was Programme Manager for Peacebuilding, Cross-Border Programme Targeting and Building Resilience amongst borderline communities in South Sudan, Sudan and Uganda border regions. In his earliest career journey, Mr. Kai had implemented complex humanitarian emergency programs in community resilience, health, education, nutrition, and livelihood. Those interventions saved lives of victims of either natural disasters or the protracted and catastrophic civil wars in the Sudan. Our third panelist is from the World Meteorological Organization, Marianne Diop-Khan. Dr. Marianne Diop-Khan studied a master's in mathematics at Dakar University, followed by a master's and PhD in meteorology at the University of Reading in the UK. She has lifelong experience in meteorology and satellite data, both operational, NWP, and research. Marianne has previously worked at Météo France and at University of Leeds and at ACMAD as the head of the forecasting department. Co-publisher of the book Meteorology of West Africa, the Forecaster's Handbook, and a number of papers. Former chair of RIDEG, former director of the Senegal Meteorological Service, and now Programme Manager at the World Meteorological Organization, Regional Office for Africa, Addis. Finally, our fourth panelist is from EUMETSAT. We have Paul Cornet, who is head of the Strategy, Communications and International Relations Department and Chef de Cabinet from the 1st of July 2016. He supports the Director General of EUMETSAT in developing and enacting the strategy for the organization, plans and enacts high-level activities with its international partners, and ensures that suitable information about EUMETSAT's goals and achievements is communicated to the media. In his role, he was responsible for drafting the last two strategy documents of EUMETSAT, Challenge 2025 and EUMETSAT, a global operational satellite agency at the heart of Europe. Before joining EUMETSAT, Paul Cornet was engaged as a full-time advisor to the European Commission, reviewing projects and invitations to tender relating to remote sensing applications directed at Europe and Africa. Paul was also very much involved in the development of projects promoting the use of EUMETSAT data in Africa, with the support of the European Commission. These projects, started in the late 90s, are still ongoing and support a vast meteorological user community in Africa. Finally, Paul is in charge of managing the bilateral cooperation agreements in place with the United States, India, Japan, China, Russia, Korea, and Canada. Thank you to all four of you for joining us in this panel discussion today. I will first raise a question to each organization individually and allow you to answer. Firstly, I have a question for the African Union Commission. Could you introduce in a few words the approach towards disaster risk reduction in Africa and which role the meteorological community is playing in that approach?
Thank you, Rachel, for the humbling introduction. And it's a pleasure to join esteemed colleague from the African Development Bank, EUMETSAT, and my colleague Marianne. To answer your question briefly, I would really like to commend the EUMETSAT for organizing this important event. And this is part of series of what we have been anticipating to ensure that there is a coordination between the hydrometeorological agencies and disaster risk management agencies. The approach that is being used for disaster risk reduction on the continent is based on four important priorities. Priority one is understanding disaster risk. And priority two, of course, is building disaster risk governance. That is also based on understanding of disaster risk. Priority number three is disaster risk financing for resilience. And priority number four is early warning, preparedness, response, and recovery and reconstruction. Now, given these four priorities, the hydrometeorological agencies have a very, very important role. First, in understanding disaster risk. At the moment, many African disaster risk management agencies are moving toward, from deterministic risk profiling to probabilistic risk profiling. And this very might depend on models and future projection of climate. In addition to that, we have seen over the times, whenever there is a disaster, that is usually, people begin to say, oh, is this because of climate change? Or this could be because of natural climate variability. And, this is a very complex issue because at the moment we don't know which extreme climate event can be attributed to climate change and which can be, attributed to the natural climate variability. And the more we have better understanding of the attribution science, and I think this is also very important to be able to have a very good, information on which data is really because of climate change. And I think hydrometeorological agencies have a daunted task when it comes to this aspect of understanding risk. And again, we also need information for risk governance. But finally, what is important, and which is also very critical, is the need for short-term weather forecast when it comes for early warning and anticipatory action. And then, of course, we also need long-term climate forecast for risk governance and risk financing.
Thank you very much, Dr. Kai. An excellent answer. Next, I have a question for the African Development Bank. The question is, the RCCs have just highlighted a few applications of Earth observation in Africa. We also understand that to run such services, a lot of data and observations need to be gathered and processed. This requires infrastructure to be in place and maintained. How important is investing in these observation infrastructures for the African Development Bank? Sorry, I think you're muted.
Okay.
Okay, I can hear you now.
Okay, thank you. And good afternoon, good morning, wherever. I'm glad to be part of this important panel, and I think it's very timely. Question about the importance of investment in the observation infrastructure. And I think we need first to put ourselves in the context why investing in the infrastructure is important or not important, but definitely it is important. First, briefly, I can tell that the situation, global situation, is like we are living in a very fragile world with lots of extreme events, and it is increasing. And this has been like predicted by the IPCC SREX report, that the frequency of extreme events will increase in terms of frequency, in terms of intensity, in terms of duration, and we are now witnessing this. Then there is also in Africa, we know that Africa is like among one of the most vulnerable continents, and the people in Africa are increasing in number. And with increasing number in African countries, the more movement, the more exposure to weathers. So there is also a need to provide those people with means by which they can adapt. And I think the information is key to adaptation. There is also, the bank is serving these vulnerable African countries. And the objective of the bank is sustainable development and poverty reduction. And to achieve this, the bank has to help countries. Most of these countries, because they're bored, because their priorities are different depending on the development status. Many of them, they don't have the capacity to provide reliable information and climate data to the people so that they can adapt or to plan. So for the bank, it's very important to have this, to invest in this infrastructure. The situation in Africa is that, according to the WMO, more than 50% of the continent service weather stations and more than 70% of the upper air weather stations are unable to capture or provide accurate data. So this is mainly due to lack of investment to upgrade or to rehabilitate this infrastructure. And there is also, as I mentioned, competing priorities. So countries are losing billions of dollars to weather and climate disasters. Millions of people across Africa are also affected annually because of these weather-related disasters. And it is not only this, the infrastructure that is suffering. There is also problems associated with inadequate human capacity, technical and institutional capacities to access, to provide climate information, and also to like engage in structured interaction with users and policymakers to mainstream weather and climate into the development plans. And as a result, there is very limited use of the Earth observation, that the information generated. So the existing information is not used properly, especially to address issues related to climate sensitive sectors like the agriculture, which is key for Africa, food security, transport, energy, and water. As such, investment in effective climate observation will definitely be economically viable, and it will bring huge return to investments through avoiding losses and damages, and also through increasing the resilience and sustainability of the investment. And this can justify more investment in this area. For example, the World Bank estimated that we need $1.5 billion US dollars to rehabilitate and to modernize the continent's weather observation system. And this is very challenging because how to mobilize this amount to help countries modernize their systems and improve their information. So for the African Development Bank, the focus on this, on addressing this issue has two folds. First, to support the climate and weather observation network, and second, to support the institutional and human capacity development. In terms of improving climate and weather observation, it aims mainly to significantly increase the coverage of climate and weather observation networks, and also to address issues related to communication channels, to address the weak access to data by different stakeholder groups, and to strengthen the development of climate and weather early warning systems. Recently, it has focused on supporting the rehabilitation and recovery of basic observation network in fragile countries like Somalia, Zambia, Liberia, and Sierra Leone. And another intervention by the bank is through this the Clean Debt Fund, because the bank is now working to enhance the application of Earth observation for climate information services in more than 25 countries in Africa. And the aim is to strengthen the network of ground and upper air observation stations to close the capacity gap. As I mentioned, there is huge capacity gap, especially in the provision of climate and weather services. The result will be building of a strong public system for the delivery of climate and weather information that can be used by different stakeholders for different purposes, from planning to management, research, and assessments. And it can also make climate-informed decisions, help institutions like the government institutions, private sectors, civil society, including even the vulnerable communities themselves, make informed decisions regarding the climate and weather, and also for civil protection, of course. In terms of institutional capacity, between 2010 and 2014, the bank financed with more than $30 million US for centers under a program called Institutional Support to African Climate Centers. It's called AfDB facility. This program aimed to strengthen the capacities of 4 regional climate centers to generate and widely communicate the climate-related information to end users. It has also supported the construction of offices and equipped the centers with modernized training facilities, as well as providing like broadband, internet, and computing facilities. The institutions, I think many of them are with us here now, Ahmed, Agroheimet, Back, and Sadiq. Another initiative is that the bank invested more than $20 million US through the Africa, Caribbean, and Pacific EU support to the satellite and weather information for disaster resilience in Africa, what we call abbreviated as SAWIDRA program. Also equipping each of these regional centers with high performance computers and improve their data analysis and modeling capabilities. In terms of human capacity, it also helped in supporting the training of a new generation of scientists and technical staff, including leading the development of numeric weather prediction tools in 25 countries. So as much as we need to improve and strengthen this international cooperation to support the infrastructure and capacity, we also need to strengthen the intra-African regional cooperation. So we should not forget about the regional integration, which is key in the field of data sharing, capacity building, and particularly in relation to climate information services and observations, because climate doesn't know borders. Thank you.
Thank you very much. Really fascinating insight. It was interesting to hear about the amount of money expected to mobilize these kinds of things, but the approach of the African Development Bank is very interesting to hear about and very promising. Our next question is for EUMETSAT. And the question is, EUMETSAT is a European organization. So why is EUMETSAT getting involved in Africa?
Thank you, Rachel, for your question. And before responding to your question, I first would like, on behalf of EUMETSAT, to really thank the African Development Bank for having organized this webinar with us, and the African Union and all the RCC to participate. To thank you all, also all participants, and finally the team in EUMETSAT who has set up this, so Rachel, Masson, Sylvia, and all the others. Now I will come to your question, why are we involved in Africa? It's very simple. It's because we are over Africa. We have a satellite which is there. And if you look at the icon of Vincent or Sylvia in the Zoom, you will see how we can observe Africa from space with METEOSAT. And we are there today, but we have been there since 1997, and we are committed to be there until 2040. So that means that we have a wealth of data which are relevant for Africa. And as you know, Africa is the continent which is the most affected by weather and climate. And we can provide weather observation, and because we have been there for a long time and we'll be there for a long time, we can also provide data which are relevant for climate monitoring. So therefore, it's really a top priority for us. It's a duty, it's an obligation for EUMETSAT to make sure that these data are made available and used in Africa. We cannot sit on these data and have not them used in Africa. So we have developed a policy in the organization. It's a policy which is supported by our 30 member states. So it's not only EUMETSAT as this, but it's 30 European member states who have really decided to do whatever we can to promote the use of the data in Africa. And the first very important political signal that we have given is that we have committed to deliver this data free of charge to all African countries and to all African institutions. And therefore, we have built this. We have built this through partnerships, a lot of partnerships in Africa with the bank, as we have seen today, with the African Union Commission, with the regional economic communities, but also with a lot of technical institutions. So this is for the African partnership, but we have also partnerships, global partnerships. We support WMO programs. And finally, we have also a big partnership with the European Union, who has been funding all these activities. So there are lots of reasons for us to be in Africa. And I think, as I said at the beginning, we are there today, but we will be there tomorrow with you. That's for sure.
Thank you, Paul Cornet, for your contribution. Our next question is for the World Meteorological Organization. We've seen examples of product development by the regional centres, but for the Earth observation services to have a real impact, they need to reach the final users in each and every country across Africa. How can this link between the regional centres and final users be completed?
Thank you, Rachel. First of all, I would like to thank EUMETSAT and the African Development Bank On behalf of the World Meteorological Organization, the Regional Office for Africa, for organizing this workshop and inviting us. And for your question, I would say that for any service, really, ideally, it has to be developed and tailored for a specific user. And it makes sense only when it has an impact, only when it reaches the final users. Earth observation services related to water, weather and climate services, national meteorological and hydrological services have a key role to play. It is their primary mandate to deliver such information at national level to ensure safety and security of lives and goods. This role is even more crucial with the changing climate, its variability and extremes, and the need for meteorological information to adapt under any circumstances and to increase the resilience of communities. So, Earth observation offers added value to such services, and the National Meteorological and Hydrological Services have the technical expertise to interpret those products, to test them, adapt them to national realities, transform them in a user-friendly language for common use. So products developed by regional centers have to be cascaded through national meteorological and hydrological services down to final users if they are really to be used in an effective manner. And I think that this also answers this morning question of Dr. Nyong. I'll stop there.
Thank you very much. At this point, to all of our attendees, I would like to remind you that through the platform Slido, the link to which has just been sent in the chat, you can contribute your own questions for the panelists, and we will select a few of them to raise in this roundtable meeting. In the meantime, I'll proceed by going back around again with some questions of our own. To the African Union Commission. According to climate change scenarios, disasters will continue to occur in Africa and may become even more extreme. What can Africa do to further mitigate the damage caused by these disasters and increase resilience?
Not only really in the future that disasters will increase. In fact, for the last 20 years, Africa is the only continent where disasters have increased exponentially. And we have seen over time, most of these disasters are becoming more severe, less predictable, and easily become borderless. And one example is the cyclone Idai that hit 4 countries at the same time. And over time, we have heard, and again, this is why it's important that we have up-to-date hydrometeorological equipment and facilities. Because over time, every disaster, people will tell you, oh, this is the first time we have this kind of a disaster. Oh, this is the first time we have this sort of severity. And I think that is very important to understand because there is less we don't know about this disaster. Sometimes even the amount of water that the cyclone carries is sometimes underestimated. And that also creates a dilemma when it comes to what kind of anticipatory action that need to be taken. So for this, and we are currently, putting in place policies. And one of these policies is to ensure that we have agile disaster early warning systems that are multi-hazard in nature. And what is important is not just putting that system in place. It also ensures that this system is linked to hydromet information. And again, it is also linked to policy makers so that early warning information is processed through appropriate authorities and action is taken, as well as necessary financing or financing instrument is put in place. And what is also important is that we also put in place, other instruments such as the Africa Risk Capacity. The Africa Risk Capacity basically is looking at the insurance aspect, especially for particular risk that can be, handled through that insurance. But again, there are limitations. The Africa Risk Capacity is only activated after a disaster is declared. Therefore, there is a need for governments to invest in anticipatory action to ensure that there is financing available before a disaster strikes. And this is the only way to go. We must prepare to invest before a disaster occurs. It's not because countries do not have resources. It is because we wait until a disaster strikes. And at the end of the day, we cannot recover. Even though people with, people are not the same, because vulnerability is not the same, based on the same people, even in the same place. So there are people who never recover, people who lost their loved ones, people who lost their own, their own infrastructure, their own livelihood. They never recover even if you replace them. So this is important that we invest early on early warning system. And again, what is important for countries to take into account given climate scenarios is the mainstreaming of disaster risk in development planning. Many African countries are starting their opportunity really to invest, in disaster risk mainstreaming to ensure that development take into account disaster risk. Roads, infrastructure, airports, hospitals, other critical infrastructure must be built taking into account climate scenarios. And we have these policies, and we are supporting countries and regional economic communities to ensure that they make investment decisions based on the future risk. Back to you, Rachel.
Thank you very much, Kai, for your excellent and interesting answer to the question. For the African Development Bank, we have the next question about the investments in infrastructure. The investments in infrastructure and human skills made in the previous years to support the RCCs, as we've learnt previously, have been very important and will be important in the future. And this is why we'll be funding or aiming to fund so much in these investments in the future. But how do you see and ensure the sustainability of these investments? I'll hand it over to you. I'm afraid you're muted. We can't hear you.
Thank you.
Oh, that's better. You're muted again. Okay.
Yes. Okay. This is a very important question because we know that sustainability is key for investment. In many cases, investment decisions will depend largely on the sustainability of the outcome. So and we are speaking about expanding and advancing and improving, modernizing the observation system. So if we are not ensuring the sustainability of the existing ones, how can we aim to expand and enhance on the future? So definitely it's very important. And one of the very important elements of sustainability is to ensure the security of financial resources for long-term investments from multiple stakeholders. This is a very wide domain, and we need partnership. We need stakeholders to work together so that they can support this process. And because we also need to bring the latest advancement in the Earth observation and the technology. And it should be invested in a way that will cater for the stakeholders' needs in terms of delivering the data and data products and knowledge. It has to function in a way that the whole observation ecosystem will be functioned in an efficient way, and it will support the sustainable development. So it should be provide a public utility for different stakeholders, particularly for development sectors. And it should it should support the planning process, the development process. And it should also support the studies, the assessment, engaging the communities, providing for coordination of efforts, and engaging diverse stakeholders, funders, users from public and private sectors, from research, from public authorities. This is key, like we are showing elements of sustainability, working together. And the follow-up for the bank's effort that I already mentioned in the last question, the bank recognizes the importance of ensuring sustainability and of the role of building partnership and alliance in this regard. So the bank is building alliance for the hydromet modernization with the World Bank, WMO, UNDP, and the French Development Agency and other partners to mobilize resources from the Green Climate Fund and from GEF resources to support like an Africa Hydromet program. This program will act as the main donor coordination mechanism in Africa and will, among other objectives, identify opportunities to help countries build the capacity to mitigate climate-related risks and disasters through modernized how to use the information to build resilience. And this is very important because sometimes you have the information, but you don't have the capacity to use the information in a proper way that will serve your purpose or your agenda. And then the other objective is to catalyze both public and private finance and mobilize innovative financing to support climate resilient and low carbon development in Africa. Through the alliance, the bank will also seek to close the hydromet capacity gap on weather, climate, hydrological, and related environmental services by 2030 through scaling up of actions. And this will, of course, support also the contribute to achieving the goal, Sustainable Development Goal number 13 on climate action. And as expected, the alliance will increase the effectiveness and sustainability of country hydromet investments, minimize competition, and improve coordination, and eliminate also duplication of investments, of course. And to cater for stakeholder needs, the bank, through the alliance partnership, is working to develop a systematic observation financing facility, abbreviated as SOF, to improve the quality weather forecast and climate analysis to ultimately lead to strengthening climate resilience. So the ultimate objective is to build resilience. And then the expected outcome will be a sustained compliance with the global basic observing network and increase access to improve weather and climate products by different stakeholders. In addition, all the efforts that have been made by the ClimDev Fund so far have achieved critical results over the 5 years of operation. It has significantly contributed to ensuring the use of weather and climate information for sustainable development, for disaster risk reduction, or adaptation, and especially for the most vulnerable communities. In this context, a follow-up program on institutional support to African Climate Centers program, it should call EUMETSAT 2, will strengthen and sustain the results from EUMETSAT 1 and satellite and weather information for disaster resilience in Africa program, implemented also by the ClimDev Fund. It will also continue to provide modern infrastructure, generate application, products, and services for climate-sensitive sectors in the bank's regional member countries. So finally, my opinion, I think there is one main element of sustainability that we need also to emphasize, and that is to provide incentives to ensure the retention of national technical capacities and expertise in the national meteorological services. As the turnover is very fast and huge, and each country can need to build a core team of climate scientists to work with users from different sectors in designing, planning, implementing climate weather information in the decision-making process to ensure sustainable development. So this is my contribution. Thank you.
Thank you ever so much. In our future efforts against climate change, sustainability and resilience is so important. And it's really important to hear attention brought to this and focus brought onto it. So thank you, and thank you for your contributions. My next question is again for EUMETSAT. Can you tell us a bit more on the new generation of EUMETSAT satellites? And what impact will these satellites have for Africa?
So I think one of the first way of describing this new generation of satellites, it's continuity. So as I already said, what is important is not to get the data every day, it's to get the data every day, but on the long run. And so with the launch of METEORSAT third generation in 2023, we will provide this continuity. However, these satellites will be quite new. They will bring new instruments. So there is also an element of innovation. And therefore, for us, it will be very important to find a good balance between both. So to make sure that the users continue to be able to do the job they do today with our satellite. But on the other hand, we shall also invest in making sure that they will take benefit of the new capacities which are offered by these satellites. So typically, we'll now have image of Africa every 10 minutes. We will also embark an instrument which is looking at the lightning, so a lightning imager, which is very important for the aircraft flying over Africa. And so there will be a lot of new things to do, and it's not only bringing new data, it's to make sure that this new data is creating new valuable information, and we believe that we would be able to reach an even wider user community. So it's not only weather and climate, but many entities dealing with the management of natural resources would be able to get access to this data and to make use of this data. So we are really enthusiastic to see this new generation. And then there is on the polar side with EPS second generation, which will be launched in the same time frame. There we are looking more at the innovation part, at the modeling part, so feeding the models, and the continuation of what we have started in the context of SAWIDRA will be very important, because these are also data which will be important, and the competencies which is very important. So we have invested quite a lot of resource in ACMAT for the time being to do this, and we hope that it will further grow. So lots of hope in these new data, and again, continuity and innovation towards to make a synthesis of what we will bring in the years to come.
Thank you very much, Paul. It's an exciting 10 years coming up for EUMETSAT and for all of the users with all of these launches coming up on the horizon. Question for the World Meteorological Organization. With the increase of disasters, how can Africa improve its early warning capacities? What are the most important investments to be made? And how can Africa prepare itself for this new generation of satellites? I pass the floor to you.
Thank you, Rachel. I think that improving Africa early warning capacity is very complex. This needs to involve all 4 components of an early warning system. That is preparedness, prevention, preparedness, response, and recovery. My colleague Kai from AUC has gone on to that, so I won't come back to that. And I think that the most important part is the first component, that is being able to detect the hazards, to monitor it, to forecast it, and being able to issue warning, which is a mandate at national level. And this is the core job of the national meteorological and hydrological services. Moreover, meteorological information is needed throughout the whole system. So investing in national meteorological and hydrological services is key to improving early warning systems. Recognizing their services, giving them the authoritative power to deliver weather, water, and climate services, as well as adequate resources, both human and infrastructure to do so. In Africa, national meteorological and hydrological services are not at the same level. We've been saying it throughout the webinar. Some are quite well off and are able to deliver well on their mission. Others are not doing it. And I think that these countries should not be left behind, and especially in this time with extreme events and when everybody wants to deliver climate services because of availability of funds, even though it may not be their mandate. And this is what AMCOMET, the African Ministerial Conference on Meteorology, is fighting for, and need the help of partners like AfDB. And I'll open a parenthesis here and call on them call on them on the implementation of the Cairo Declaration and the need to establish the CDSF AMCOMET Fund Facility. AMCOMET seeks to strengthen all national meteorological and hydrological services, as well as the regional climate centers and the regional specialized meteorological centers, which are responsible for extreme weather forecasts. And these regionalized specialized meteorological centers are implementing the severe weather forecasting demonstration projects and are capacitating the national meteorological and hydrological services to better forecast extreme events. So and AMCOMET can also provide advice to donors and development partners on priority areas to invest and close the capacity gaps of national meteorological services and as well as the regional centers. And in one sentence, I would say that we need to invest in national meteorological and hydrological services, and we need policies and framework to position those service providers appropriately so that they can generate and apply knowledge-based information, but with differentiated responsibilities. Back to you, Raquel. Oh, I had another question. It was 2 questions on how can Africa get prepared for the new generation of the satellite.
We only need a brief answer to this.
Yes, I can answer. Because for that, I think that Africa need to get information on the kind of data that will be generated, how to access them, how to process them, and how to use them. I know that national meteorological and hydrological services have been informed through the RADEC group, the expert group, WMO expert group, on dissemination of satellite data. I know the constraint on the bandwidth to send all data and the infrastructure, its capacity building, but they should find ways of overcoming these problems and build gradually their own capability rather than just being eternal consumers or receivers. The bank has invested a lot on RCCs, but again, warning is done at national level, and national meteorological services need to get capacitated to make optimum use of all the data that the new generation of satellite can offer. AUC and EUMETSAT have been supporting the national met services through PUMA, MSD, and MESA on accessing EUMETSAT data from 2 generations of satellites. And I think that for the 3rd generation, we need to find a sustainable mechanism for the use and the exploitation of the data. Thank you. Back to you.
Thank you very much. We have had a few questions come in through Slido now, which I will raise to the members of the panel they were directed at. Firstly, I'd like to apologise for being slightly over our time schedule. You'll see now that we're at 10 minutes to the hour, when originally we were projected to finish at 1/2 the hour. However, we've had such good input and results from this panel discussion that we will push it forward and end on the hour. So in Germany time, that's 5 o'clock. In UTC, that is 3 p.m. We will finish then. We will raise as many Slido questions as we can until that point and then wrap up the webinar. So first audience question I have is directed to the African Development Bank. The audience member asks, I like the African Development Bank vision to close the hydromet gap in Africa by 2030. Can you do that without getting governments across all levels on the continent to prioritise hydrometeorological services in their national budgets.
Can you repeat the question? I didn't hear it.
The person says, I like the African Development Bank vision to close the hydro-met gap in Africa by 2030. Can you do that without getting governments across all levels on the continent to prioritize hydrometeorological services in their national budgets?
Yeah, of course. I think this is very valid. And I also agree with this question that without the government put this closing the gap as a priority, it will not, no matter how the funds from the bank or the alliance can be, it cannot be, it has to be, it has to come from it to be national interest. And this is a question that I cannot answer, but definitely I agree that government should be part of the process, should prioritize it first, and come together, put their hands with the funders or donors, and work together. Because definitely the government now are well aware of the importance of this observation infrastructure and the need for information and early warning, the forecast, so that they can prepare for disasters. Definitely the situation during very recent situation, the floods, for example, in 1 month, from August to September, the 1.2 million people in Africa, in 12 countries in Africa, have been impacted by the floods only. So one climatic event in 1 month, 1.2 million in 12 countries in Africa. So you can imagine other climatic events, drought and excessive temperature and the impacts. So the countries are well aware, definitely, of the importance of preparedness. And maybe sometimes we need this type of disasters to raise issues to the top priority. So yeah, we don't need disasters to do this, but sometimes it has to be. And I think what is happening now will induce countries to prioritize issues of climate change and particularly related to information and early warning.
I see. Thank you very much. It's a shame that that's how it is sometimes, that disasters are what it takes to make a change. But when there are so many funding priorities out there, we'll make the changes that we need to do. Our next question from the audience is for the WMO. Samuel asks, what is the plan to support and strengthen capacities in satellite meteorology through helping the centres and the NMHS to have satellite application facilities that will provide Africa-tailored satellite products? So essentially from Samuel to the WMO, what is the plan for strengthening the satellite capabilities?
WMO run a training workshop to train to train staff from national meteorological offices and hydrological offices to use the satellite data. And there are some exchange that can be organized from the national developing countries to the developed countries so that they get the expertise. And we're also having some scholarship for students to learn satellite meteorology.
Okay, thank you very much. We have our final question from the Slido that we will address today, and this question is directed to EUMETSAT. Question is EUMETSAT ready to support meteorological services and climate services centres to have their own nano micro satellite in space, so that Africa can have direct access to polar orbit satellites to improve NWP and DRR response and build capacity of the continent in Earth observations? Thank you, Paul.
So clearly we are committed to this, but maybe not in the way which has been expressed in the question. So we are committed to this because we are doing it already with the SAWIDRA project and the HAR. So we are deploying a network of antennas in Africa to get real-time access to our polar orbiting satellites. But this will also give access to other types of polar orbiting satellites from the United States or from China. So there will be a capacity to have real-time access to the data. So this will support this type of applications. In parallel to this, together with WMO, we are trying to set up the training capacity, so to make sure that there are people which are well educated to use the data. And in the future, as a meteorological space agency, we also plan to fly our own constellation of microsatellite to complement the observation of the big ones. So my message is that there will be data available. We try to set up an infrastructure so that this data could be acquired in Africa in real time and processed. We will invest on the pillar of education to make sure that the data could be used. So it's a partial response. It's not the role of EUMETSAT to support the development of satellite by African countries. So this is not in the mandate of the organization, but within the mandate of the organization, we are working towards what has been raised in this question.
Thank you very much, Paul. I have one final question actually that's just come in through the Slido for the African Union Commission. Is there sharing of experience, products, operational services related to DRR amongst the regions? To the AUC, I hand the floor to you.
So Rachel, I think you cut off. Could you kindly repeat the question?
Okay. Is there sharing of experience, products, operational services related to DRR among the regions? Is our question from the audience.
Sure. Yeah, we have a number of platforms where African countries share experiences. We also have a number of tools that we have employed to ensure data collection and data sharing. The first one is we have what we call the biennial report on disaster risk reduction. This is a report that is done every 2 years. The first report was launched recently by the president of the Gambia in August 2020. And the next report is expected to be out next year. So this is a report that compiles all the best practices and the progress many African countries are making toward the implementation of the Africa Program of Action for Disaster Risk Reduction. That is one way. We also have a platform which we call the Africa Regional Platform on Disaster Risk Reduction. This is also done every 2 years and is a platform that brings all African countries together to showcase their experiences, their lessons, and which provide also an opportunity for other countries to learn from. And a number of partners, including AfDB, are key players in this platform, and also EUMETSAT also has been part of it. We also have a working group on disaster risk reduction. This is a smaller version of the Africa Regional Forum, and this working group meets every 6 months. And although it does not, accommodate all the countries, there are a number of countries representing regions and the regional economic communities, and a number of partners, most technical partners working on DRR are part of that. So there are a number of platforms for data sharing on the continent.
All right, thank you very much for your answer. And that brings us to the end of our roundtable panel discussion. I would like to thank Balgis Osman-Lasha from the AfDB, Marianne Diop-Kane from WMHO, Gadkueth Kai from African Union Commission, Paul Cornet from EUMETSAT. I'd like to thank all 4 of you for taking part in this panel discussion and for your contributions to the webinar. This brings us to the end of our webinar on Earth observation in Africa. We'd like to again thank the collaborative efforts of the African Development Bank, the Climate for Development in Africa Special Fund, the European Organisation for the Exploitation of Meteorological Satellites, and Africa's 5 regional climate centres, who all together have made this webinar possible and together have constructed such a fantastic day of so much information, so many learning opportunities, and so many fascinating people to hear from. New perspectives, new insights, and new perspectives on the future. It's been an excellent webinar, and I hope that everyone agrees. About the availability of this webinar afterwards, soon after the end of this session, we hope that the entire video will be available on the EUMETSAT YouTube channel, and our partners may link to this video in other places. If you have registered for the webinar online and are now present in the Zoom call, we have your email and we will be able to send you copies of the presentations afterwards. As for that, I thank you very much from EUMETSAT and on behalf of our partners for joining us today.